Hey there, everybody, and welcome back to more Adventures with Cadence. This is Jacob here. I'm sure you're so excited to be hearing my voice again because I am awesome. But we are going to be going over contract interfaces in this video. So this may remind you of resource interfaces, where you went over that with Morgan last week. And what that was, to kind of give you a quick example here, I'll pull up this example contract. And what you were looking at is something like this, right? Where you have public resource interface, test resource interface, and you say, okay, we want this resource to have an X in it, right? So let's say we defined a resource named test resource. You would have to, if this implemented test resource interface, you get an error. And this is saying because hello world.test resource, which is this resource, does not conform to resource interface. And this is basically saying that if this resource implements this interface, it has to have the things that this defines. So we would have to put, for example, a public let x be int, and of course we would have to initialize this and yada yada yada. But I'll just do this super quick so that you'll see the errors go away. Now this is fine. So this is what you did in resource interfaces. And what I want to show you now is contract interfaces, which is a very similar concept, but it's really important in Cadence, and you will see a bunch of examples of this during week 2, where we actually download a project from dapstarter or a foundation, and we'll walk through some contracts together that will actually implement contract interfaces. So what this is it's the exact same as resource interfaces, except for a contract. So we can define in OX01 here a contract interface, test contract interface, and we will, let's just put public let x be an int, and I don't know, what else do we want? Let's say we want a public function called, I don't know, get x, and in it we will return an int because we just want to return x here, and we'll have this sort of function here. And let's say that in this function we wanted to have a post condition, which I will go over in a second. But let's have a post condition that result, which is the return value that we return from getX. Because remember, we aren't actually implementing this function. We're just kind of defining it of what it should look like because this is a contract interface. So the result should equal self.x. And all this is saying is that in whatever contract that implements this contract interface, it must have an x, and it must have a public function getX that returns x. And if it doesn't, we'll get an error. And I will show you this in a second. So let's say that we just defined our contract interface to be this, right? Let's deploy this. And hopefully it won't take too long. Okay, so it deployed to contract OX01. So let's go into an actual contract now. And let's call this, I don't know, test contract, right? That implements the test contract interface from OX01. And it's saying this contract does not conform to contract interface test contract interface. And why is that, right? Well, it's because we haven't actually defined our, x here. And what else do we need? We need a public function getX. Okay, so public function getX. And this returns an int. And so, the problem here is that right in the contract interface, we were just kind of defining what these should be. Now, obviously this looks similar, but this looks a little different, right? In here, we were saying, okay, the post is at the result, which is what we're returning, equals self.x. Well, in our actual contract, we're going to write this function, right? And so let's say we want this function to, I don't know, log self.x, and then we wanted to return self.x, okay? And, it's complaining that we didn't initialize x, so I'll just do that really quickly so that we don't see an error here. Self.x equals 10. And so it's still giving us a problem here. So contract test contract does not conform to contract test contract interface. Well, why is it doing that? Let's go back. To be honest, I don't really know why. It should be. So I have to refresh. Oh, that's why. Because Playground is annoying. So we actually did conform to the test contract interface, and I'm glad that this error comes up so you can see it's not just you. The Playground is always buggy. But so we can actually deploy this now, and you'll see that this goes through. Now, you might be asking, well, okay, this function, defines it in the post, the result must equal self.x. So let's say that someone in here returned 10, right? Well, this works because we're returning an int, and it will actually, the playground will let us deploy this, and you can deploy this. However, when you actually call this contract, it will give you an error. And actually, I should make this like 12 so that it's different from x. And let's try and see what happens if we redeploy this, right? Well, playground is being buggy again. But let me just refresh the page and deploy this again. Or actually, I think I have to deploy this one first, right? And then this one. So let's go to a script, and let's actually import test contract from OX01 or OX02. And let's actually log, I don't know, test contract dot get x, right? So let's log what this is returning. We're not going to return it into here. So let's see what happens when we call this. Post condition failed. Now, do you understand why this post condition failed? It's because of the fact that in our contract interface, we said that test contract has to have a function get x, which it does, but the post is that the result, which is what we're returning, this int, has to equal self.x. And in this case, that wasn't true, right? So this kind of shows you how you can add an extra layer of security and how you can tell developers that, implement your contract interface what you want them to return. And so in this case, we would have to put self.x. And so if we put this here, if it doesn't give us any errors, and it's giving us errors, so I won't go through that, but this will work. And so lastly, I'll kind of go through a little more that we can do. So let's say we wanted to define a public resource interface inside of a contract interface called INFT. And I'm going to start introducing you to ways in which Flow deals with NFTs and why it's so good for NFTs as well. So let's say in here we have public let y, I don't know, be an int, and here we'll let public let y be an int. I know I went a little fast there, but all I'm doing is saying we have a public resource INFT, and we're going to have NFT implement the INFT resource interface, right? So we've added a little more. Now let's see what happens when we deploy this. So this gets deployed, and then, if we refresh this page, it'll say the contract does not conform to the interface, and this makes sense because we simply have not defined either of these two. Now, the thing is that when we in our contract interface put a public resource interface like this, we actually don't have to put this in our contract. All this is saying is that we have to have a public resource called NFT that implements this public resource interface, and I'll show you what I mean by that. So in here, we have to say public resource NFT that implements not INFT, or, maybe you were thinking that we would copy paste this and put this here. No, that's not what we do. What we do is we get rid of this and we say public resource NFT implements test contract interface.inft, and in here we will have to put public let y be an int. And obviously it's going to give us errors again because we haven't knitted this, but let's just say self.y equals 10. So this will work. So my point here is that if you have in your contract interface, a resource interface, and then you have a resource that implements this resource, it's saying that this, whatever NFT you define, implements this specific one. So we can't redefine INFT in here. It always implements this one. So hopefully I have convinced you that contract interfaces are cool. And let me, show you a real example of where this might be used. So this is the Flow Non-Fungible Token Standard. So if you ever see NFTs being traded on the Flow blockchain, all of those NFTs all abide by this standard. And you'll see there's a ton of comments because they wanted to make it very clear, but you'll see they have a public contract interface non-fungible token that has a total supply, so every contract must have a total supply. They have a bunch of events, and I'll just go through this quickly. They have an INFT that I showed you before. They have an NFT that implements this specific INFT. They have resource interfaces. They have, more resource interfaces. They have a resource called collection that implements these resource interfaces. So you can see how we can take our very simple example and we can expand it to NFTs, which are a huge thing in the Flow, blockchain network and for blockchain in general. I'm sure you've heard a ton about NFTs, and so there really is a lot you can do with this. And just as an example, I've come up with just a simple example NFT that implements the non-fungible token standard in OX04, and you can see I put total supply, I put the events. I have a resource called NFT that implements the non-fungible token.inft. I have a collection. So I know I'm repeating myself, but I want to really express how cool contract interfaces can be, and we will use a bunch of these during week 2 and 3. So thank you so much for coming to my Cadence TED Talk. I hope you're enjoying these videos, and keep going on. You're doing great. That's awesome. And I'll see you in the next one.